All right, so our next method of factoring we're going to learn about is factoring trinomials, specifically trinomials of this form. So trinomials, remember, that means we have three terms. That's what the tri stands for. So as you can see here, 1, 2, 3 terms. This format requires two things very important. We need a degree of 2. So we need to have 2 as the highest power. And also we need to have no coefficient or coefficient of 1 on that x squared term. If all those things are true, then we can use the methods that we're going to learn in this section. Failed so bad taking all that stuff off. So if it's in this format, we can use it. So this first question, definitely in that format. We have a degree 2, 3 terms, nothing in front of the x squared, so we're good to go. So what this is going to come down to is that whenever we distribute these little binomial terms, whenever we do that FOIL that you guys probably remember from high school, this is got to be something that looks like this. We need to have an x and an x in the first terms of both of those binomials. This is going to give us x squared when we go to FOIL out, which is what we need for our first term. We also know that the last term of a FOIL, right, the last multiplication that we do, the number times the number, has got to be this 16, right? And then the middle terms, they're the ones that are going to combine to this 8. So if we wanted to, we could even go ahead and put placeholders in here to sort of see what happens, but we don't need to. I think most of us have seen this before, and I'm just going to kind of jump straight into it. Another way to think about this, we need to think about the fact that we need this to be a product, and we need this to be a sum, is what we're going to find. There are two schools of thought on how to do this as a student. We know we have an x squared and a 16. If you wanted to set this up using the area or using that box for multiplication, well, what we need is we need to figure out how to split up this 8x in a meaningful way. How do I put it into these two boxes so that it's actually useful? So one thing you could do is try breaking up 8x into like x and 7x, 2x and 6x. Eventually you'll land on 4x and 4x. And if you go to figure out what the GCF is, right, kind of unmultiplying this, between 4x and 16, the GCF is 4. Between x squared and 4x, the GCF is just x. Same thing along this side, we're going to have x and 4 again. And everything works out. In fact, this thing here just factors to x plus 4 times x plus 4. 4 and 4 multiply together to be 16. And then if we do the outer and the inner portions of this, we get 4x and 4x. And we add all this together, we get our x squared plus 8x plus 16. Now this is not necessarily the most efficient way to do this. Trying to split up the 8x to me gives a lot more options than trying to figure out what things multiply to 16, using the multiples of 16 to our advantage instead. So as another example to test out, let's just look at another simple one, x squared plus 14x plus 24. So if we wanted to factor that, we are going to manipulate or use the fact that we know that this is the product of the numbers, right? When we multiply the last of each of those binomials together, it has to be 24. And we're going to use the fact that this must be the sum of the numbers. So there's a lot of ways to do this. I personally love a table. So I want to find the factors of 24. This table is particularly useful when you're going to try to figure out if something is prime. It's very hard to be like, did I try everything, unless you make a very anal retentive list. So that's what we're going to do. So we need things that multiply to 24. And I like to do these in order. So 1 times 24 is 24. 2 times 12 is 24. 3 also goes into 24 8 times. 4 goes into 24 6 times. And then 5 isn't going to work. It does not go evenly into 24. 6 we already have, so forth and so on. So this is it. This is the complete list of factors of 24. Now we need to figure out what these things sum to, because specifically we're hoping to find one that equals 14, right? So we sum, we got 25, 14. This is obviously our winner, 11 and 10. So what this tells us is that if we wanted to do the sort of area method, or if we wanted to do factoring by grouping, or any of the or the AC method that we're going to learn in the next section, is that we could take that 14x and we could split that 14x up into a 12x and a 2. And then we could fit a 2x. And then we could figure out exactly what would have needed to be here in order for this to work out. So the greatest common factor of 2x and 24 is 2. X squared and 12 is x. X squared and 2x is x. And 12x and 24 is 12. So this here just foils into x plus 12, x, or reverse foils into x plus 12, x plus 2. If we multiply these back out, we're going to get exactly what we hoped for. We'll see the last is going to give me 24 as expected. The first is going to give me the x squared as expected. And for those middle terms, we get a 2x plus a 12x, which is my 14x. So I can sort of double check as I go that this is the correct answer. All right, now it can get slightly harder than this, though not really, but we can deal with the other types of signs and really focus on what the heck the signs tell us for these B and C terms. So let's look at another example. So let's just do x squared minus 2x minus 15. If we wanted to factor this, well, first off, we look at our final term, right? This tells us what we need to have multiplied to. So in this case, we need two things that multiply to negative 15. In order for this to actually be negative, the signs on our two pieces have to be opposites, right? They have to be opposite signs. So if we're going to sit there and make up our little list of factors of 15, in this case, factors of negative 15, 1 and 15, 3 and 5, and those are the only things that multiply to 15. Now, one of them needs to be negative. So technically, we can make two different versions, right? One where I make the 1 negative, one where I make the 15 negative, one where I make the 3 negative, and one where I make the 5 negative. But this is really unnecessary to do all of these. What we should do is we should use this, the number that they have to sum to, our B, to figure out what has to be happen here. So they need to sum to a negative 2. For them to sum to a negative 2, that means the bigger number has to be negative, right? Look at these sums. This one is 14, positive 2, negative 14, negative 2. So I didn't really need to write down these first two. I should have immediately known, because this is negative, the bigger term must be negative. If it had been positive, the bigger term needs to be positive, because the bigger of the two is the one that's going to determine what sign the addition goes to, right? Once you get those numbers, we're not even going to bother to write out that little box thing on this one. We know that that's just how this factors. X plus 3, x minus 5, I'm sure 15. They will multiply together to my negative 15. They will add together to my negative 2. This is perfect. So one more, and then I'm going to let you guys try a couple examples. So the last one I want to do as an example, let's do k squared minus 7k plus 10. All right, so again, the pluses and minuses here tell us a lot. The plus on the last term tells us that our two numbers have the same signs. They're either both positive or they're both negative. A negative means they have opposite, and a positive means they have the same sign, right? Because a positive times a positive would be positive. A negative times a negative would be positive as well. Now, we're going to again use that middle term to help us out. Since our numbers added to a negative 7, right? This is our add. Since they added to a negative 7, the only possibility is that they are both negative. If they're positive, when you add them together, it's going to be positive. So we know what our answer choices look like. So we start here and we go, okay, we need our factors of 10. We know that they're both negative. So we have 1 times 10 and 2 times 5. Knowing that both are negative, and then we can check our sums. Negative 11, negative 7. This is the one we needed. We're done. Well, not done. We have to write this, but So I'm going to give you guys maybe 3 more to try, like one of each type of the harder ones. So I want you guys to try out. Let's do the first one. Let's do, that one's good. X squared minus X minus 42. I want you just to factor these. I'm going to give you a couple more. Let's do, want them to be difficult enough that this is exciting. Let's just do X squared minus 9X plus 20. And as the last one, we've done the negative, 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 positive. Let's try a positive, negative for you guys to do. Let's do X squared plus 2X minus 15. I hope that's not the one we just did. I'm checking. No, we didn't do that one. Cool. So those are the 3 for you guys to try. Take a moment, pause the video, make sure you can do all 3. All right, so now that you're back, 42, again, you could have made your entire list. Factors of 42, 1 and 42, 2 and 21. 3 goes into 42 14 times, and 4 goes into, does 4 go in there? No, but 6 does. 6 goes in to 42 7 times. Since we have a negative sign here on the back half, opposite signs, right? Since my middle term is negative, this must be the bigger one. So throw negatives on all the bigger ones here, and then we add them together. Negative 1, negative 11, negative 19, and negative 41. We need negative 1, even though there's nothing in there. There's a 1 that we can put in as a placeholder. So that's our winner. And our factored version is x minus 7, x plus 6. The order you write these two in does not matter at all. All right, next one. We need to multiply to a positive 20. So that means they have the same sign, right? Either positive, positive, negative, negative. Since my middle term is negative, it's got to be negative, negative. So again, you can make your list. I'm going to just jump us to the right answer. X minus 4, x minus 5. Negative 4 times a negative 5 is a positive 20. Add together, it's a negative 9. And then our last one, again, we see this negative 15 on the end, which means that we have opposite signs. Since my middle term is positive, this means the positive must be the bigger number. So if we were to make our list of different factors, 15 we already did earlier on a question. We got 1 and 15. We have 3 and 5. The bigger one has to be positive, so that's what we're testing out. And then if we look at those sums, positive 14, positive 2, this is what we're looking for. And we're done. As I said in class, this breaking these up and figuring out the factors becomes way easier with practice. At some point you get very good. You know how all of these, what multiplies to pretty much all the numbers you'll see in these questions. Before that, it is a little tough, but hopefully that helps out. Remember, always make your table and use those negatives and positives to really tell you what's going on.